Hi everyone, this week, which is week 6, even though it says 7 up there, is about problem solving with probability and statistics. And mostly here I'm going to focus on probability. In this lecture I'm not going to tell you many theories or ideas, I'm just going to give you a whole pile of problems to think about, maybe some clues. And what I want you to do is go away this week and try some of them and see if you can come up with some solutions. And then these problems are going to be revisited again in your workshop. Probability is a really fun part of mathematics, and yet it's one of the least understood parts. Often it's because in probability, probability is about chances or possibilities, where in mathematics we're often concerned with certainty. And so people get a little confused here about what it means and how we can work things out. So just because something's got a probability of a half of happening, it doesn't mean if you did that thing 10 times that you'd get 5 of one outcome and 5 of the other. You might get 10 of the outcome because it's not about actualities, it's just about chances. So here's some famous problems to think about. Some you'll be familiar with and some you will have never heard of before. The first one has been around for a long time. It's called the Monty's Door problem. If you read a book called A Strange Incident That Happened to a Dog in the Night, I recommend you read it if you're going to be a teacher. It's about a boy with Asperger's syndrome. This is a problem in there that's solved, and if you need a solution, you could look in that, as even though it's a novel. The Monty's Door problem goes like this. That you go on a game show and there's 3 doors. Behind one door, and you're randomly selected from the audience, and behind one door is $1 million. Behind the other 2 doors, there is nothing. And then you're asked to choose a door, and you do, and just before you open it, someone else from the audience who you don't know is randomly selected. And they are asked to open a door, not your one, and when they do, it's empty. Okay, so if I've gone too quick through that, these slides are again on the Learning at Griffith site, you can have a look. But the question now is, do you want to change your mind? Right, so there's $1 million at stake here. Do you want to change your mind, or do you want to stick with the one you've already chosen? And then that's your investigation to think about. Now the problem here with this, whenever I've posed this problem, which I've done many times before, is most people don't even think about the mathematics involved. They just go, oh, I'm not changing my mind, because if I did and I was wrong, I would be really devastated. So that's one way of thinking about it. Another answer I've had is, I wouldn't change my mind because the producers, they're just trying to trick you. They're just trying to trick you. But remember, in this case, the person who's opened the door is just a random person from the audience who did not know where the money was. So, what's your initial response? I've given you a couple I've had commonly before. But the next important question is, how could you investigate? Because what's happened is they've got to this point and all of a sudden the show said, oh, we're out of time. We're going to come back next week and you can choose. So how could you investigate this question? What would give you the best chance of being correct? And I want you to explore this and try and play with the idea and see what you come up with and be prepared to discuss it in your tutorial this week, because I've asked your tutors to have a look at this problem. Now, you might want to stop now and do that, or you might want to wait because there's a second part to this problem. So Monty's Door problem, you're randomly selected from the audience. Behind one door is $1 million and behind the other 2 doors is nothing. You choose a door, and just before you open it, in this case, the show's producer, who is the only person who knows where the money is, comes and opens a door, not yours, and it's empty. And so the question again is, now do you want to change your mind? Or is this exactly the same as before? So again, same questions as last time. Can you investigate it and work out what is the solution here? I will give you a hint. In one of these situations, you should change your mind, and in the other one, it doesn't matter. So see if you can investigate and find out why. All right, so the other examples I want to give you here are I know you're going to be teachers, but these are certainly ones you probably don't want to use in schools because they're going to be from the casino. But what I've tried to do here is choose problems that might be of interest and relevance to you. Here on the Gold Coast, we've got the flashy casino, the Star, that they've just done up. There's also the one in Brisbane as well. So casinos are commonly around us, and I know that many people lose a lot of money in casinos. So let's look at some of the casino games. So the casino, the first one there, you can see I've got a roulette wheel. How do casinos make so much money? Now, again, you've probably read over the papers over the last few years that the corruption and that of the casinos in Melbourne have landed the casino running companies, I think it's the Star, I might be wrong, one of the other ones, in all sorts of hot water, in the point that they're going to get their license revoked so they can't run a casino. But if you've ever been to a casino, they're pretty opulent. I went to one in Las Vegas one time, and we were just going there for a sports event, but we got to Las Vegas and we're staying in the hotel, which happened to have a casino, which they all do. You got to the front of the hotel and you walk in the front door and you don't go to the reception of the hotel. As soon as you go in straight away, it's the casino. You walk in and there's straight into the casino. To get to the desk to check in, you have to walk right through the casino to the check-in desk at the back. And the reason is most people, before they even got to check in, have already started spending money in the casino. These casinos had huge chandeliers, beautiful carpet, very opulent. Obviously, they're making a lot of money. They'd have a restaurant there, and this time, the one I went to, for $2 you could eat as much as you want. And this was not just junky food. This was all high-end food, good quality food. It was right at the back of the casino. The reason is the casino operators didn't want you to leave the casino to go and get something to eat, because you might go into someone else's casino. They wanted you to stay in there. So casinos make an awful lot of money. So how do they do it? Well, maybe it's because they're really good at probability and most punters are not so good. So these are just a couple of investigations you can look at about what are the probabilities involved and how you can understand why casinos are making so much money. So if you consider the roulette wheel, this is one sort of roulette wheel. You'll notice, if you can see it there, it's got a green 0 at the top. Some of them in Australia have a green 0 and a green 00. And then other than that, they have the 36 numbers, half red and half black. So the question here, what is the sample space? Now, but the sample space just means what are all the possible outcomes that could occur, and are they equally likely? So on a roulette wheel, it's relatively easy. What is the sample space? Well, it's all the numbers. But the numbers are 0, and often 0, 0, 1, 2, 3, 4, 5, right up to 36. So if it's got 0 and 00, how many numbers are there in the sample space? There's 38. But because the only numbers are up to 36, people assume it's 36, but there's 38. So the sample space is just what are the possible outcomes, and you can see on a roulette wheel they're all equally likely to happen. Despite what people say in most of the casinos in Australia and other countries where they're highly regulated, they are not cheating, they're not rigged, they can't possibly be. If you go to some cheaper places, I'm sure they are, but mostly they're not rigged, they don't need to be. So what's your chances of getting a red number? Well, people look at it and go, oh, well, half the numbers are red. So the chances are there's 18 red numbers and we go up to 36. So the chances are 18 out of 36. But remember, there's not 36 numbers, there's 37 or there's 38. So your chances of getting a red number are not 18 out of 36, they're 18 out of 37 or 18 out of 38. So you can see there's a very slight difference there. But if you bet on red and you win, what happens? They double your money. In other words, they treat it as if your chances are 1 out of 2. So in this situation, how does a casino make money? What's the casino's chances of winning? Well, if we just choose the example that you can see there with the 0 and no 00, the chances of a casino winning is normally people bet on red or black. Now you can bet on green, but not many people would. Most people bet on red or black, and there's many other options, but let's just go with that one. And so the chances of red winning are 18 out of 37. The chance of black winning is 18 out of 37. And the chance of the casino winning is 1 out of 37. Now, what happens if red comes up? Well, mostly in the long run, about half the people bet on red and half bet on black. So if black comes up, they don't really give you, the casino doesn't give you their money, they just take the money off the losers and give it to the winners. So if red came up, they take the money off the black people, black numbers who people who betted on the black, and give it to the people who bet on the red. And then once out of every 37 times, the casino takes everything. Now let's say this casino table had, I don't know, conservatively, if you've never been to a casino, it's fun to go and have a watch, but they often have, let's say $1,000 on the table. And if they do it about once every minute, I think they go a bit quicker than that, but let's say they do it once every minute, then every 37 minutes, the casino will make $1,000. And the rest of the time, they're just swapping money from one to another. So every 37 minutes, they make $1,000 on every roulette table they've got, and they might have 50 of them. You can see how they can quickly make a lot of money. Now, another game we can play only in Australia, I haven't seen it anywhere else, is the game of two up. And coming up to Anzac Day, it's actually legal to do it in places, but most of the time the only place you can do it is in a casino. And it's not common in many Australian casinos, it is in the Adelaide casino. And what happens is you flick 2 coins and you can either bet on heads or tails. And if 2 heads come up, then the people who bet on heads win. If 2 tails come up, the people who bet on tails win. If a head and a tail comes up, then what happens is 1 light comes up in this little box that I've drawn across there. And then if the light comes on, then they'll do it again. They'll toss the coins again. If 2 heads come up, they pay out heads. If 2 tails come up, they pay out tails. If a head and a tail comes up, the second red light will come on. Same again to the 3rd, 4th and 5th. Now, if you get to the 5th one and all 5 red lights are on, the casino takes all the money. So again, the question would be, what's the sample space? What's the possible outcomes? And you can see this one's a little bit more complicated than the last one. But you could use a tree diagram to have a look at this. And again, you might explore it in your workshop. What are your chances of winning? Well, people again think it's 1 out of 2, but in fact, that's not the case. What are the chances of the casino winning? Well, they have to get a head and a tail 5 times in a row. And the chance of that is 1 out of 32. So again, this is worth investigating to see how the casinos make money on a game like that. And how much money might they make? Well, again, they play these games about once every minute, and you can imagine how much money's on these tables. All right, I would not use those 2 in schools. I don't want to have anything that possibly could be seen as encouraging gambling, but I think they're interesting for you as university students to explore. If you explore them, the one thing I hope you learn more than anything else is if you gamble in a casino, in the end you lose. The people who win are not any of the punters, although some might win for a while. In the end, if you gamble, you lose, and the people who win are the ones who are running it. That's why they run these things. Here's one I have used in schools, and it's about a race. And I've listed 12 runners there, and we just roll 2 dice and add them up. And if we roll the 2 dice and the number comes up of your horse, you fill in the first square. If your number comes up again, you fill in the second square, and if it comes up a 3rd time, you win. And so we'd play this in class. And the kids would bet on all sorts of numbers. Interestingly, when the kids choose their numbers, they would say, depending on what code of football might be played in their area or what their favourite player was, they often chose the number based on who their favourite player was. Interestingly, if you're in Queensland and other places where a rugby league is popular, often their favourite player is number 1 because the fullback, and so a lot of kids chose 1. Now, if you know anything about the probability of rolling a 1 by adding up 2 normal dice, you will realise that number 1's not a great choice. But we'd play this game and then we could explore it and see whether it's fair and who would win and where would be the best place which would be the best horse to choose to be your winner. Now, after we've done that for a while and investigated the mathematics of it and explored it, and you can again do that, you might do it in your tutorial, but you can also use, this is one you could use if you're a school teacher as well. What would be the next one I would give it if I was in a school? The next one I gave them was this. So remember, they've done the previous one and they've worked out that number 7 is winning most of the time. We've explored the probability, we've taken the context, and then we've done it in mathematical terms, and they all understand that about how you can get 7 most commonly with 2 dice. So then I say, well, what about this one? You'll see we've taken out number 1 because no one wants to bet on number 1 because it's an impossible event, and you can talk about impossible events in the context of that first race. So in the second race, I say, well, is this now a fair one? Is this fair? Now, in fact, this is fair, but the students will deny vehemently that this is fair because it doesn't look fair. Number 7's got to do a lot more to win than the others. So again, there's the follow-up. Do they understand the mathematics? And in this case, often the context means the mathematics doesn't mean anything. They just go with what looks right. And in probability, that's the challenge. So here's one that doesn't look fair, but in fact is fair. And how could you investigate that? And then after we've done that one, we could play a third game. And this is the one I'll put up next. Again, you could use this one in schools when you're teaching. You know, upper primary or early secondary would all be okay doing these. And this is one you might do in your shoot. So here's the third activity. This is called diffie. Instead of adding the dice together, we find the difference. And player A wins if the difference is 0, 1 or 2, and player B wins if the difference is 3, 4 or 5. And the question is this a fair game? And if it's not a fair game, how could you adjust the rules so it is fair? So I'm going to leave that one with you to think about, and again, your tutors might pick that one up. Here's another one way of thinking about probability. I mean, what I'm trying to show here is that probability should always be done in the context of games or activities where there's chance involved. And let's face it, almost all games involve some level of chance because we use dice and other spinners and things to try and make them work. And the chances of winning have to be fair for people, so it's just not dominated by luck. And luck will be something you need to talk about in your class. But there has to be an element of probability and trying to work that out, which is important to do, and they can do it in the context of games. How can you make your chances best? So for a gala day, you need to invent a game that will look inviting and fair, but will make the school some money. Okay, so when you have gala, if you go out and become a teacher in schools don't do it so much anymore, but some still have a fair or a day where they put on all these things to try and raise money for the school. And you have to invent a game where people are going to have to bet some money, pay some money and try and win a prize. So the job for the students, and the job for you here, would be to invent that game, but you need to make sure when you invent it, it looks fair and looks inviting and people are going to play it. They're not going to look at it and say, no, I've got no chance. All right, and you've seen them at the show days and things like that. But you've got to make sure that in the end you'll actually make money for the school. And then you've got to work out how much you would charge and what the prizes would be. So it's another example of probability in action. If you can't teach probability in interesting and fun ways, then you're probably really struggling to teach maths well at all, because this is the easy one. All right, so that's a few ideas, and I hope you have fun playing with them and trying them out, but also learn some mathematics and try and work out how probability works and how we can make it accessible and how we can work with people's preconceptions about luck and things like that using mathematics. Okay, all the best.